All right, let's see how we can use RGuroo as our technology tool to work with the normal distribution. So at this point, we know what the normal distribution is, and this video is to kind of show how to find values for given probabilities or probabilities for given values. So I have your homework, problems from your homework from Newton Alta here, and then I have RGuroo opened in here, and I hope that I'm sharing my screen. I think so. All right, so then okay, so let me close here. So in RGuroo, where you need to go to the probability simulation tab. You go to probability, and this is the same like the same area we were working for chapter 4. You go to probability calculator. So chapter 4 was all about the discrete distributions. We work with the binomial for the discrete. For chapter 5, the normal distribution is actually a continuous distribution, meaning that we have a variable that can have any given number within an interval. Like you think about discrete is a variable like that have numbers that you use to count, so that you have 1, 2, 3, 4, 5, just whole numbers. When we talk about continuous distributions or continuous variables, then we have a continuum of values. Like if you're measuring distance, you can have 5.3, but you can have also 5.25, you can have 6.11, you can have any given number when you measure that distance in between 2 points or 2 things. So then we are working with a continuous. All right, so then let's talk about RGuroo before we head to work on problems. So here is your pretty much calculator, right? So something that I need you to notice is this 2 things in here. So this one says values to probabilities, and then this one is probability to values. So then we're going to use this when the problem is asking us to find the probability that your variable gets values at least of X amount of number. For this one is when the problem is giving you the probability, and then you need to find the value that hit that tail at the beginning or at the end. Again, we have a set of distributions that are continuous. For now, we're only talking about the normal distribution. For the normal distribution, as we already know, the parameters for the normal distribution are always the mean and the standard deviation. And this goes back to the empirical rule that we talk about in chapter 2. So the empirical distribution said that we have a bell-shaped distribution, and then if we center that distribution at the mean, we can go 1, 2, and 3 standard deviations to the right and left of the mean, and then that empirical distribution tells us that within 1 standard deviation of the mean, we have approximately 68% of the data points. If we go within 2 standard deviations, we have 95% of the data point. If we go within 3 standard deviations, then we have 99.7% of our data points. So then it's pretty much the same in here. The mean is where we're centering our distribution. Standard deviation is, you know, how many like the units we're going away from the mean. And then in here, we have options in terms of our tail. Do we want to go to the left for the lower tail? Do we want to go to the right for the upper tail? Do we want to stay within the 2 tails looking outside, like inside looking towards the mean? Or do we want to go outside, meaning from a point to the right or to the left to just get the tails? So then how do we use all this? Let's go here. So this one says to use the normal distribution to compute a value for a random variable. So we have a tire company. A tire company finds the lifespan for one brand of its tires. It's normally distributed with a mean of 47,500 miles and a standard deviation of 3,000 miles. What millage could correspond to the highest 3% of tires? So then let's go back here and see which one of these we need, because that's the first thing that we need to figure out. Are we talking about given values and we need to find the probabilities, or is it giving me a probability for me to find a value? Remember, probability, it's area under the curve. So we have that bell-shaped curve, and here it's telling me that I want to find a value, a millage, that corresponds to the highest 3% of tires. So then we are talking about an upper tail towards the right to the highest values. And I want to enclose 0.03, which is the 3% of tires. Then we go here, we write the mean, which is 47,500. And then standard deviation, it's given to us, is 3,000. No commas, just the numbers. 47,500 for the miles for the mean, 3,000 miles for the standard deviation. We want the upper 3%, so we have the upper tail, the highest values of the distribution, and I want to enclose that 3% of the area under the curve. I'm going to hit here the graph so I can show you what are we doing. And then remember, every time we do want to do this in RGuroo, we need the blue eye. All right, so then here is what kind of what we have. This is our normal distribution. Remember, it's a bell shape. We have our mean in here, some like this highest point in here. This value in here is the 47,500. And then we go 1, 2, 3 standard deviation to the right and to the left to cover pretty much the 100% of our distribution, all right? So then we only need the highest 3%. So this is the yellow area that I have here like highlighted. So this area under the curve, this yellow shaded area, it's 3% of the whole area underneath the curve, like all this space in here. So this 3% of the area is after the 53,142 miles. So this is the value that correspond to the highest 3% of the tire. So it says to round the answer to the nearest integer. So this is going to be, and I'm going to go back here, 53,142. And that should be the rounding for it. So that's the value again, is this value given to you right here. It's this one as well. Okay, I cannot highlight it. So there's this value in here. All right, and so we submit that. So that's one of the problems. Let's see what we get next. All right, awesome. It switched me. All right, so then it says the average speed of a car on the highway is 85 kilometers per hour. With a standard deviation of 5 kilometers per hour. Assume the speed of the car, that's our variable, that's what we're measuring, the speed of the car. It's normally distributed. This is actually telling you that we can work with something like this, that we have a mean and we have a standard deviation, and that if we go 1, 2, 3 and standard deviations away from the mean, we have that 68, 95, 99.7 of our data set. We want to find the probability that the speed is less than 80 miles per hour. So then I'll go here, I'll do the same thing. So I'll go to probability and I'm going to open a new calculator. And so now it's asking us for a probability. We want to find the probability that the speed is less than 80. So then we want to find a probability and they give us values, right? That value is the 80 kilometers per hour. So let's just feel the same thing. We always need the mean. We always need the standard deviation. So mean is 85. It's this first number given to us right here. Standard deviation of 5. So that goes here. Standard deviation is 5. And then Less than 80 means that we want to go below 80. And I'll do the same. I'll hit here to see the graph. And so we go here. And so again, we have our curve with our mean at 85. We go 1, 2, 3 standard deviations to the right. And then we go 1, 2, 3 standard deviations to the left to have our bell-shaped distribution. 80 is just right here. So we are kind of, this is the signal, we like our line, right? And because it's less than, it's telling me to go to the left. So then if I go to the left of 80, I shade the yellow region. And then now what I'm trying to find is what is this area underneath the curve to the left of 80. That is your probability. That's what the probability means. Probability means area underneath the curve. And actually, we need 4 decimal places. The probability is right here. So the probability that your variable is less than or equal to 80 is 0.1587. So if I go here, 0.15871587, that is our probability. And there we go. All right. So it's either you're given the value like this green line, and you need to find the shaded region, or they give you the shaded region and you need to find the value of the line. Let's see what we get next. All right, so let's do the same thing again. So it says, a credit card company receives numerous phone calls throughout the day from customers reporting fraud and billing disputes. Most of these callers are put on hold until a company operator is free to help them. The company has determined that the length of time a caller is on hold, it's normally distributed. So again, it's continuous because the time, it's a continuous variable. With a mean of 2.5, so we have a mean of 2.5 and a standard deviation of 0.5 minutes. If 1.5% of the callers are put on hold for longer than X minute, what is the value of X? So let's open a new one. Continuous. Let's write what we have. So we know the standard deviation, the mean is 2.5. We know the standard deviation is 0.5. All right, and they know that 1.5% of the callers are put on hold for longer than X minutes. What is the value of X? X is a value and it's telling you in here, right? We're finding a value then, and we're given a probability. This 1.5% is what we need to find in the graph. So then we need to change this to probability, two values. We're given a probability to find a value. And so it says, if 1.5% of the callers are put on hold for longer than X minute, what is the value of X? So I want the upper tail, and then I want the 0.015, which is the area underneath the curve for the right side. All right, so then again, this is your curve. This is this mean here from 2.5, and then I go plus 0.5, plus 0.5, plus 0.5. That's 3 standard deviations to the right. And then so it says round your answer to 2 decimal places, and that's actually what I have. So I'm going to try that 3.59. All right, and so again, let's kind of back up in here in what I did. You have your mean, you have your standard deviation, and you put that just in here, mean, standard deviation. All right, so then it says, if 1.5 of the callers are put on hold for longer than X minutes, so then I will say 1.5% of the callers needs to or wait more than 3.59 minutes. That's what this is telling me. The 3.59, it's the value that that like hold that place for the 1.5 upper tail, which is the people that wait the most, or that the people that is put on hold for the longest time. All right. Okay, let's do one more. Okay, so let's read again. Let me open a new one. New one. Here. All right, so I said a one poorly set up machine is observed to produce components whose length X follows a normal distribution with a mean of 14 centimeters and a standard deviation of 3 centimeters. We need to calculate the probability that the length of a component lies between 19 and 21. And I'm really happy that we got this one. All right, so we have values. It's telling us to calculate a probability. So again, if you need to calculate a probability, then you start with the values given and you need to find the probability. So this is the right direction. So mean for this one is 14. Standard deviation for this one is 3. And then here you have the in-between, all right? So you don't have to do it twice. And this is the benefits from RGuroo and a calculator. In the calculator, you will have to know how to work with the PDF and the CDF function, and then do the subtraction in between the two of them, because there is no way for the calculators to do in between probability. So in here, you do the in between. The lower tail is 19. That's the minimum value. And then the upper, which is the maximum value, is 21. And I'll do the graph and I'll click the eye so you see what we're doing, all right? So then we have, again, our normal bell-shaped distribution with the mean in 14. And then we go 3 up and 3 down for the rest, like to simulate the normal distribution. I want to find the probability. Again, probability is area under the curve in between 19 and 21. So you have 19, the green line, all the way to 21, the other green line. This yellow shaped area in here, it's 0.03798%, not percent, but it's gonna be 3.7 or 3.8% of your area. If I account for the area starting here and all this thing underneath the curve, this in here represents that 3.8%, right? We're going to leave that in proportions always. And it says to round to 4 decimal places. So I have 0.379. So that's going to be an 8. All right. So this is how you use RGuroo to find probabilities or values depending on what you have. Again, you always need, if you go here again, you always need the mean, you always need the standard deviation. Be very mindful when you are reading your problem that what you are given is actually your standard deviation and it's not your variance. And once you have that, make sure that you understand direction. It's less than, or it's more than, or it's in between, or is it outside. And then the graph can help you see, like it's going to give you like a visual if you're actually doing what the problem is telling you to do in terms of direction, because it's going to turn yellow. You're going to want, do you want upper tail, or do you want a lower tail, or do you want an in-between area underneath the curve? All right, so again, this is 6.2.2, and I hope that the recording is helpful for you to finish your homework.